Hi guys, it's me again, Yagman. I only have a really shitty light on my phone. Not all of us can be millionaires and afford lamps. Anyway, I found this really cool game that I just wanted to share with you all. Yeah, I'll put the link in the description and you can play it. It's a game based on your reactions and music. I'm really, really bad at reaction games. So yeah, we'll see how we go.
Hello, my name is Carlos, as Mark said. I'm half of HelloEnjoy. This is the other half. And we have another addition to HelloEnjoy, which is like a quarter. And we live and work in the lovely town of Brighton in the UK. And we build things, we build games, music visualizations, creative apps, all these kind of things in 3D. I started working in 3D when I joined Psygnosis back in almost 20 years ago. And since then, I started working in, you haven't seen this logo before in this presentation, in Flash, and really enjoy Flash. One of the things I moved from PlayStation to Flash was because when you do a PlayStation game, even PlayStation 1 games that were much better than they are now, it used to be like a very long project, like maybe 3-year project, and at the end, almost no one you knew would see it. It was something like working for very specialized market, and you never actually met anyone that has seen it before. So you did a game, but none of your friends seen the game unless they went to your house. It's really like working for a very niche market. What I really like of the web and Flash is that what you did there was universally available to everybody. And that's something that is being like the main objective of my career, basically, that my work is available for everybody. I also wanted to do some 3D, that the one I was doing in PlayStation back in Flash, so I could do both, like have nice 3D visuals and also being able to show it to everybody. I developed the 3D engine Paper Vision with a few friends, did things like this. And you probably have seen it in this session today, that a lot of people coming here to speak, they talk about personal projects. They talk about things they are passionate about. And that's something that's very important for us because it's what really drives us. And in our case, we do also client work, but we can't afford, clients can't go as far as we do. Clients have responsibilities to their audience. They can't just go and bet on a technology, even if the technology is not popular. They need actually to make sense, to make business sense of what they hire us to do for them. But we can do personal projects that can go in any direction we want. And I think that's very important, to be able to explore different directions. Also, if you depend on what people commission you to do, you end up just going into some direction which is normally everybody's direction. So we think it's important that you do your own direction, that you find your own direction. After Paper Vision, after Flash, we produced 3 projects that are very close to us because there are 3 personal projects. First one is called HelloRacer. It looks like this. And it was one of the first WebGL demos that was basically available, that wasn't something geometric or some particles. It was something that was easily understandable by people that didn't know what WebGL was. WebGL, in case you don't know, is a technology to do 3D natively inside the browser. So HelloRacer was very popular. It became the benchmark for developing WebGL. It's been used by Google, Firefox, Opera, and now Microsoft to test their WebGL implementations. Then we did HelloFlower, which is an application for iPad done in Unity and allows people to design their own 3D flowers. It was created in Unity, which is a very nice 3D development environment. So basically allows you to do 3D in a very easy way. You have a very nice editor where you can actually see things, see what's going on. And then today we are showing HelloRun, which is an HTML5 game that uses WebGL and web audio and has music by our friends at Dutonk in London. So we're going to take a look at the game from different angles. This is a project that is it's like an indie game for us because it's something that is done by us personally and has really no budget. So it's not like when we work for clients, we can get really expensive designers and really good people just throwing assets at them, and sometimes we work in projects that are very high budgets, but this is not the case. This is a very low budget project that was done completely by us, so that's why we actually like it. It was done in HTML5, and here's the importance of HTML5. Basically, how we see HTML5 is that at the moment you have webs and you have apps, and there's like a line between them. And basically HTML5 and the new capabilities like WebGL and web audio allow us to basically blur the frontier between webs and apps. I think this is very important because for some type of content is not suitable for app, and some type of content is not suitable for web either. So at the moment is this division between webs and apps, which I think doesn't make any sense, especially from the user point of view. There's this thing now called web app that's like apps that are really webs, and that's like the future for the next year or 2 years. Everybody's doing that now. We got an email from Amazon. Amazon is opening a web app store for Kindle, and everybody's doing web app now. Like Tyson is doing web apps, and who else? Leapmotion also has web apps. So web apps is it's good because you can package the website into an app, and this process of packaging the web into an app is standard. It's something that W3C is approved, so it's not like everybody has their own package system. It's like universal package for webs, but still there's a bit of issues there how native the web is when it's become an app. But as you can see, this web versus app frontier will get blurred, and hopefully in a few years no one will know if what they're looking at is a website or is an app, and that will be great for everybody because people will be able to click on a link they see on Twitter and they will go and see the content without thinking, oh, it's a website, or it's an app, I have to download it, or it's a website, I can't go back to it, I can't see it offline. So all these things will probably disappear, which will be good for everybody. This means that probably JavaScript is going to become the platform, the universal platform where things are written. There will be probably languages and higher level platforms on top of it, but probably what we're looking in the future is to be everything done in JavaScript, like it or not. So with this consideration, our challenge here is how to make nice things in JavaScript. There's a few things that we need to this is how JavaScript looks to us now. And to do something visual like this, especially coming from Flash, where at least in Flash we had an editor, quite a nice editor, and you will be able to do your own things and some little animations. And that added so much feedback when you do something visual that instead when you have to do it by numbers and by code, it's so difficult. You have to test all the time, every change, and it's difficult just to get the feel of what you're doing. On the other side, you look at Unity, which has a very nice editor where you can just click on things and sliders and adjust colors, everything in real time. So hopefully we will find a workflow that involves a nice editor like Unity. There's a few companies doing that. There's PLAY&MAKE, and it's like 3 or 4 companies now trying to do Unities for WebGL, basically. And at the moment, they are starting now, and some of them are very promising, but they're still not a clear winner. It's difficult because if you want to run an editor inside the browser, which is what most are doing, it's not going to be as powerful as a native editor, which Unity is. But I think everybody's going into that direction again. So hopefully in a few years, when there won't be any difference between apps and web, we will have nice editors so we can do things visually. The process we use at the moment involves doing things in Photoshop, Illustrator, and Maya, and then sending them to Unity to convert them into a format that we can read in WebGL. The process is detailed in our blog at HelloEnjoy.com, but basically what we're using is the Collada format, which we were using already in Papervision, but we use it now as an intermediate format. So everything that we create gets exported into Collada, and then that gets imported into the 3JS editor, and then gets exported again as native 3JS asset. This process, the good thing about this is that we are relying on open technologies, and it's not like proprietary exporter that I do, and then when they change the version of 3JS, we have to change the exporter again. Hopefully this workflow will be stable enough so we can be using it for a while. We rely on a number of open source software: 3JS by Mr. Doob, the 3D engine, Howler by Goldfire Studios for the sound, and PX Loader by Pixel Lab for the loading. Again, it's very important not to reinvent the wheel and trying to make your own things. I normally do that. I'm always like hitting my head against the wall because it's always like much better solutions available everywhere. So let's take a look at the game. You can go full screen, which is very nice. Oh, sorry.
Two worlds apart. I don't want to leave the world that's us here. It's all that we know.
Well, you get the idea. Thank you. So, looking at the game from different angles, first one is game design, where this comes from. And we've done games for clients like this one and this one, but we haven't done a game for ourselves in ages, so it was a good opportunity to design something that we wanted to do instead of something that we're just being asked to do for a client. So inspiration-wise, I wanted something simple, and the inspiration from this one comes from the Star Wars arcade machine, the trench run, which is the one level which looks like this, which is actually very similar to what the game looks. And you basically go up and down, avoiding the barriers. What they had, they had also some shooting and some enemies shooting at you and you shooting enemies. We didn't like that. We wanted something much simpler, which is, I think, is a current trend in games. This is a good example of what we wanted in terms of simplicity, which is Super Hexagon. It's a game that could have a lot more things, but they don't have, the designer didn't put those things in just to bloat the game. It's a very simple game. It doesn't have power-ups. It doesn't have anything really. It's very hard, but it's very nice to play. It's very, you get into the mood of play and you get the flow of the game very quickly. And that's something we wanted to do. We also wanted, there's something that frustrates me of games, that they get progressively difficult until they are impossible. I didn't like that. We wanted to have a bit of different approach to that, because that's more or less good for an arcade game where people are paying money, and then after 3 minutes you want them to lose basically and pay money again. But for a game that is not designed to do that, then there's no point going like difficult, impossible. So we wanted to have like a little, you are difficult, and then if you pass that, you get a bit of a rest, and then you get a bit more difficulty. For that reason, we wanted the music to be able to dictate the pace of the game, and the music to be able to go up, and then go down, and then go up, and then go down. And then to get the people in the flow, in the right flow. And this is something that, I mean, when you do online work, you never get to see the people playing with your games or your experiences. I mean, you always, like, you might read comments or tweets, but you don't see them these days. But recently, this trend of actually playing games and recording themselves, and they post it in YouTube, which we find it great. And we can see actually how people play games. And this is only happening in games at the moment, but it's incredible how people are getting used to, like the girl you saw at the beginning. They play the game and they tape themselves, and you can see exactly how they feel about the game, when they fail, which parts they like, which parts they don't like. And that's very valuable for us. It's like having like a focus group doing testing, but on YouTube, and they do it on their own. And it is good to see how people, if people get the idea of the game, or they just don't like it at all. For the graphics, there's a few things, a few elements, not many, but a few elements. The environment is the most important one. It was created by Michael Orkis, also called Killstar, and he's a very good modeler, very trendy at the moment. The model is like a square like this. We want to have something very simple so it can fit on mobile. So we didn't want to have something dynamic. It was a very static model. And for this type of work, we don't want to be able to, we don't want to render the whole environment all the time. So we divide it in corridors. So this one is divided in the four corridors. So basically we do kind of occlusion cooling by showing only the corridors that the user can see. So if you're running through this corridor, you won't be rendering the corridor behind. For the textures, which is I think the most important part, because the model is actually very simple. What makes it nice is the combination of textures. We're using two types of textures. One of them gives it color and detail, and the other one gives it lighting and depth. This is the model with the color only. The color is tiled, because the tile texture like this, you can see it has tiles that they are repeated, like the floor is made of tiles. So by having the same tile repeated, we can give a lot of detail, because we can have a lot of resolution in the texture, and because the texture is repeated, we can have a lot of pixels in the, you can see here, you can see the tiles repeated on the floor, on the wall, and because it's the same tile, we get a lot of resolution there, we get a lot of detail. You can see it here in a little bit. You can see it doesn't have as much depth, but you can see all the detail on the different elements there. On the opposite side, we have the lighting. Lighting is calculated in Unity using Beast, which is a very advanced lighting system for games. And this is the opposite. In lighting, the texture looks like this, and it has 1 pixel per, each pixel is unique to a particular place in the environment. So that means that there's not much resolution. It looks like this. It looks a bit ugly because there's not much resolution, but when you combine this with the detail, you get the final result, which has both depth and has detail. And that's combining resolution of the textures so you can have detail and you can have variation, which is in the case of the lighting, is what makes the whole thing work. It's very important that this is probably the most difficult part to get right. How much you dedicate to the lighting and how much you dedicate to the detail or the color of the texture. You can see the lighting here. Same thing, but only the light. No detail, no color, really. And then we have the lighting effects, how we turn on the light, turn off the light. This is done by something called emission, which is like having a particular part of the texture, like here, for example. Here we are, everything you see here, except for the gate at the end, all the environment around it is the same texture, the same material. How do we make some parts glow and be bright and some parts stay dark? We do that by, in the detailed texture, we signal which parts are going to be brighter by doing that in the alpha channel. So we use the alpha channel of the texture to mark the parts that are basically bright and leave the parts that are opaque or black or dark black. This way we can basically do this. We can control some of the intensity of the light of the environment at the same time without changing the rest of the lights, basically. And we also use a technique called color light mapping, which means that we use RGB to light the environment. So we use red lights, blue lights, only two. We could have used green lights, but we didn't want to have more lighting. So that way we can replace inside the shader the red and the blue colors, and then we can create here. You can see how it's a bit orange, the light there, and it's bluish outside. We can control those colors outside, so we can basically have the ability to modify the lighting in real time without being costly, without calculating any lights. That's the environment, how it works. The barriers, we had a lot of ideas, but the problem with the barriers is that when you play the game and you're going fast and want to go fast, it's difficult if the design of the barriers is not clear enough for the eye to perceive how they are configured. It's very easy to just crash because you don't see how the gate is done. So we had some ideas like this, initially going left, right, and up and down, but then that was too complicated. We had ideas of making, first we had the idea of making like a sphere character, a bit like a robot, sphere robot, but we prefer to be in first person. That was, you get better feeling of speed, and also having gates like this, which look great, but when you have few of them stuck one on top of the other, it's like impossible to understand what you're looking at. These were another try that we did. It's easier to understand visually, but again, not as good. This one was very, very difficult. We do all these tests in Unity because we can prototype there very quickly. And this is the final one, which first is based on the hexagon shape, which is more or less the shape of the corridor, but also we just focus on the center because that's what you're really looking at. And then you can see if basically the three parts of the barrier, which one is on and which one is off, so that allows you to go very quickly through them. We place them manually by hand in Unity. So we use Unity as a bit of like when you used to do Flash, you probably were coding using FDT or Flex, and then you had the Flash editor to just make up your SWC, and you could do you put your things together there, and then you export, and then you do the coding somewhere else. We do the same technique now. We use Unity to place things and to put where things are, and then we use JavaScript to do all the coding there. So we place the gates here manually. You can see where they are, and we also in Unity created the path where the center of the corridor is. So that way we can go up and down, and we always keeping that line in the center, so when the user goes up or down, they don't go behind the floor or below the floor or above the ceiling. So we always have to keep them in the area. This is an example of the different variations you can find, like 2 open at the top, or maybe 1 open at the top. There's a few configurations. They are actually mirror, so we could only have the texture for half of it, and the other half is actually a mirror of the left part. We only have the left part. And this is all the different variations we have. We have to do this texture by hand in Photoshop. And you can see the planes where they were, and the center, which is very important, because if you get the center wrong, then you might get the feeling that you're going through, but then you crash, or the opposite. So it was very important to get that right. And this is for the effects of the lights themselves, of the barriers themselves. They have like a little scan line that moves through it, and they have a little smoke. The smoke is made of this texture, of the green part of the texture, and the scan lines are made of the red part of the texture. So the shader basically takes this texture and uses the red part of the texture just to move it like scan lines. They move a little bit like that, and then it uses the green part, the green channel, and it made the green channel, but much bigger than it is there, like scale, and it also moves it slowly over it, so that you get that feeling of, you can see it here, of having some scan lines there and some kind of misty effect. I mean, when you do this initially and you don't do these scan lines and this smoke thing, it looks very cheap. It looks like very polygon. So we have to add effects on top of it so it looks a bit more realistic. UI was very hard because we have to do it in HTML using CSS. And the challenge for the UI was to make it responsive, to use fonts as well. I mean, it's a lot of HTML things we had to learn from there. The idea for the UI was to keep the same thing. It reacts to the mouse a little bit. It has some screens here. And it's also this little anecdote that when we launched initially at Reasons to Be Creative in September, we launched it on the 3rd of September, and 2 days later we had an email from Media Temple saying that we were over quota on the bandwidth. Only 2 days later, and we basically had to be paying like 100 quid every day to keep the site running. So we called our friends at RZRS, which are the Influxys guys, and asked them nicely if they would host it for us, and they are providing the hosting as well for free, which is very nice from them, because sometimes you need to calculate how, if you launch a project like this, you need to take into account hosting, a lot of things that you normally don't do when you do work for a client, especially if things are a bit successful, then suddenly you start getting into running costs that escalate very quickly. For the fonts, again, that's something that we wanted to give a bit of attention. With HTML5, you now have the possibility of having different fonts on the screen. And we wanted to have, first for the logo, we tried a few different things. We had this idea of, we wanted to have something very like sci-fi, but also have a bit of disco, of club thing in the middle of it. So we always going like, is it going to be very sci-fi or is it going to be a bit disco? So we were trying to balance both. At the end, we went for the logo to be a bit sci-fi and for the music to be a bit more disco-ish. So we think it works fine. We try a few variations for the logo. We use this font, which is a very nice font. It's very new as well. It doesn't look like futuristic retro. It looks, to us at least, it looks like modern. Futuristic things, we find that sometimes they look like futuristic from the 80s, which doesn't look futuristic anymore. So we wanted to have, for the fonts that were designed recently, and they were a bit modern in terms of visual. These are the fonts we try also for the UI, and again wanted something very slick, very not futuristic basically, but like machine-like. We ended up using this font, which is called Stereo Gothic. One thing, especially when you are working with fonts in HTML5, is that it's good that the font you select has a lot of weights. So because sometimes you put the text there and it doesn't look right, especially if it is small, it might look too thin or it might be too dark. So if the font has a number of weights, you can basically change the weight of the font until you find something that looks nice. So selecting the font is not only creatively, but you also have to think about technical issues like how the font is going to look, and then you have to test it in different browsers and mobile and see how the font looks in different places. And you find a lot of surprises there. So it's important that the font, this one has 9 different weights, so we are able to pick the ones that look good. For the audio, we did this project 2 years ago for Ellie Goulding for Interscope Records. It was a music visualization. We want to keep on using music and evolving the ways of visualizing music. And for this project, we got in touch with these guys. They are like an indie band called Utong. They are based in London and Sydney. And they are very nice guys, and they like the game, and so it would be nice to get the music there. We're using Web Audio API, which is like a new thing also. It's not HTML5 strictly, but it goes along with HTML5 and is supported by many browsers now, and Firefox was the one that was lagging behind, but they are adopting Web Audio now. And with Web Audio, we can change the playback rate, so when you crash, you can do this record end effect, and then we have also this audio node. This is how Web Audio works, and we noticed that not many people are using Web Audio, and it's a shame because it's very nice technology, and we want to encourage people to use it. So this is like a 30-second tutorial. Basically, it's made out of nodes, Web Audio, and you have like a source node that plays the sound, and a destination, which is normally the speaker or where the sound gets played. And you have something like this at the beginning, and then you start adding like nodes. It's very easy. You just say which node connects to which one, and you basically create something like this. At the end, we didn't use something that complicated. For this project, we used the analyzer node. So we have the original sound, we have the analyzer, and then we have the output. And the analyzer gives us this. It gives us real-time analysis of how the sound is. And you can see that we use that to control the lights and the textures that we were saying before. Again, it's very important that you use web audio. I think it's one of the most promising technologies in HTML5. We're very, very pleased with it. And mobile is the final frontier for us. It's very important that we work towards making our work universally compatible with all types of devices. I mean, with the iPhone and Android and all these mobile devices, we suddenly found a division again between things that are designed for desktop and things that are designed for mobile, or things that are designed for both but look shit. So yeah, I mean, it's a bit of compromise. You either go for both, but it's going to be really boring, or you go for desktop. So for us, it was very important to all our future work works at least on both platforms. What we do here is that we disable some effects on mobile, but we'll still be able to run the game on mobile and do all the lighting effects and do the web audio thing as well. This is the Nirvana that we dream of, to be able to do the same thing and then it runs everywhere like it used to be in the old days. And within these are the technologies that will be bringing us to this Nirvana. Basically, WebGL to do some 3D and 2D graphics that are fast. Web audio to do all sorts of audio manipulations, to be able to basically manage audio the same way we manage graphics. And then full screen, so we can forget we are inside the browser. When you combine these three technologies, you basically get a native-like experience inside the browser, which is amazing. And now with the new, in Chrome, Android, now you can basically create a bookmark inside the home screen, and then you can click the button there, like the icon, like if it is a normal app, and then it opens the browser and it goes full screen, and then you have your WebGL, they are working. So suddenly it's like so close to be a native app, but it's not really, it's a website. So we are going always in this direction, as we think these three technologies are very important. This is HelloRun on Android, on our Nexus 7 tablet. One of the biggest pain in the ass that we have making things mobile friendly is the responsive design, which here you might see a lot of 3D things happening, but we also have the responsive design as well. So when the user even has the phone vertically, we put the text together, we move text, we change the size of the text. We do that using the usual media queries things that you do in CSS, so we had to learn how to do all that. So even if you're doing kind of heavy graphics experiences now, you still need to learn how to do the responsive bit, because if you want your content to be on all platforms, you need to basically be able to show the text and lay out your screen for each different platform. And also is the fragmentation problem, which again makes things more difficult, because now we not only have different devices and mobile and desktop, but we also have different browsers in the devices. So we have Firefox on Android, we have Opera on Android, we have Chrome on Android, and then we have those on desktop as well, and we have different mobile platforms. So that adds a lot of how different platforms behave, and that's a bit of a pain again. So you need to be able to test on different platforms. But again, the final result of being able to have the same code, the same website running all across different devices is so great that it's worth the pain of testing and understanding each different platform browser combination. For the controls, again, we were supporting mouse. Touchpad is probably the best option to play the game. We support keyboard for those that like to play with the keyboard. We support touch, obviously, for we found that with all these mobile devices getting WebGL, we look at, oh, we're going to have our WebGL pieces working there, but they don't work because they need to be able to support touch. So now our previous WebGL work, we will need to update it so it can be used on mobile devices. So it's good to, from the start, to think about having, when you're doing the input of your piece, to do not only mouse or keyboard, but also think about touch, because it's kind of important in the future. And we also do lip motion. You can see it here, the little test. It's very difficult to play lip motion, but it's kind of fun. So you can go up and then go down. That's more or less how it works. And you can see the game here, HelloRun.HelloEnjoy.com, and that's HelloRun for you. And then we have a new project that Mark mentioned, which is, this is the story of the project. As I mentioned before, HelloRacer was used for developing, is being used for developing WebGL, for testing WebGL on browsers all across the different companies. So we got an email from Samsung, and they were using HelloRacer to do some devices and testing. And they wanted us to add some things to it and to add sound, because they were also doing web audio, and they didn't find a demo of web audio, and they wanted to show it together. And they also wanted to use it for like meetings and business things. So we worked with them. We worked with the engineers in Korea. That was very fun because they don't speak English. My English is terrible, but they didn't, so it was great. But on the other side, they were the engineers, so we were sending code and they were changing our code and sending it back to us. And sometimes there were bugs in their code, so we have to find workaround. And it was great because it was different type of client, very technical, very like, I change your code and you do as I say with the code, which I'm not used to that. But on the other side, they were creatively, they very happy with us. And basically, they didn't have any say creatively. So this is called RZRS. And it's a little demo that we did for Samsung to show WebGL on their mobile phones. And it looks like this. Where is it? Here. It uses Doppler effect in web audio, so you can have the, oh, sorry. It uses Doppler effect, so it calculates the speed of the car and the position, and then you can, when you get inside the car, it's louder. When you get out, and you can look around. And that's it. And you can see it here in helloracer.com/RZRS. It's become a little song of HelloRacer, so hopefully it will be used. It's still got some issues I just found on Mark's phone, but it's been designed for mobile specifically. It doesn't do anything extra on desktop, so everything you see on the computer is also what you see on mobile. Differently from HelloRun. HelloRun is like designed a bit for computers, and when you go to mobile, some things are disabled. Here is the same thing. So we want to have like a mobile design WebGL experience. And you can play it here. Or not play, because you can't play, but you can see it. And that's it. If you want anything from us, HelloEnjoy, HelloEnjoy.com. And we also want to post in our website some technical tutorials so people can get to see how we do things, and basically trying to make great experiences on mobile. So basically Apple is the last one to get into the WebGL list, but we put some pressure and we have to basically get back into do cool things like we were doing before on both desktop and mobile. Thank you.